Hi everybody and welcome to our math video. Today we will talk about Leonhard Euler and the 7 bridges of Koenigsberg. Leonhard Euler was a Swiss mathematician and physicist. He made important discoveries in many branches such as graph theory, analytic number theory, or also trigonometry. Furthermore, he discovered the famous constant E, which is also called Euler's number. He spent parts of his life in Prussia in a small town called Koenigsberg, today known as Kaliningrad in Russia. This town is famous for its 7 bridges. A river separates the town in 4 landmasses which are connected by these 7 bridges. One day, when Euler crossed one of the bridges, he asked himself an interesting question. Is it possible to cross all 7 bridges without traversing one bridge twice? This was the birth of the graph theory. To introduce you to the solution, let's start with the basics. In the graph theory, there are 3 important elements. The first 2 are nodes and vectors. A node is a point which connects the different vectors, such as a crossroad or a roundabout connects the streets in your daily life. So to stay with our example, the vectors are the streets which lead to the crossroad or the roundabout. However, we have to differentiate between 2 kinds of vectors. The ones with direction, such as a one-way road, and the ones without a direction, equally to a normal road. Nevertheless, for Euler's problem, only vectors without a direction matter. The last important element is the degree. Every node has a degree. It describes how many vectors are connected to the node. This sounds complicated, but let's simplify it with some examples. This node has a degree of 2, because 2 vectors lead to the node. This node, however, has a degree of 3. So now that you know the basics, let's get to the solution. Euler found a mathematical way to decide whether it is possible or not to draw a figure without using a line twice. If this is possible, it is called a Eulerian path. For a Eulerian path, 2 conditions must be fulfilled. First, all vectors have to be directionless. Second, only 2 or no nodes may have an odd degree. Let's do the most famous Eulerian path together. In Germany, it is known as the House of St. Nicholas, and it is a well-known drawing riddle among young people. The task is to draw the house without lifting the pen and also without drawing a line twice. As we now know, this could be an Eulerian path. So let's check the rules. As we see, every vector is directionless. Therefore, the first condition is fulfilled. Now we look at the nodes. The first node has a degree of 2. The nodes in the middle have a degree of 4, and the last nodes have a degree of 3. Thus, the second condition is also true. 2 nodes have an odd degree. Hence, the task is possible, so let's try. As you can see, the rule works, and the house is a perfect example for an Eulerian path. However, what about the 7 bridges? First of all, we simplify the problem with a graph. The nodes represent the landmasses, while the vectors stand for the bridges. Next, let's check the conditions. The bridges are directionless, so the first condition is fulfilled. Now let's look at the second one. If we count the degrees, soon we will see that the condition is not fulfilled. All of the nodes have an odd degree. That's why the answer to Euler's question is no. Sadly, he realized that his beautiful promenade over all the 7 bridges would always be a dream. So he continued to discover further things to distract himself from the disappointment. As you now got an introduction into graph theory, hopefully you understood the concept of the Eulerian path and you can plan your walk before you leave and won't be disappointed if it doesn't work. Thanks for watching our video.
There are 7 bridges to be crossed, 7 years of darkness to survive, 7 times in a